Day 10, last lecture before the exam. There are no lectures for the next 2 days. There are some review materials posted. There is no quiz 10, but this material will be on the exam. In fact, today's lecture is going to be brief, and you're like, yeah, we've heard that before. I'm actually only going to go through the first page of this, and then I want you to work it and make sure you really understand what's going on. So the goals for today are you're going to be working with confidence intervals for population mean, factors that impact the p-value, and factors that impact the confidence interval. So make sure you go through this, and I did post the solution. Really though, if you can work this stuff, it's going to be much better. You'll have really internalized it much more. Remember, we learn by doing. We're from Poly. So we're pulling some concepts together. Are confidence intervals and this is a little bit wrap up. Confidence intervals and significance levels related? Yes. Remember significance levels being those where we test the p-value and compare p-values to various values to see how strong the evidence is. That's what we're talking about here. So let's say we have an example where we compute the 95% confidence interval. In this example, the interval of plausible values is called the 95% confidence interval for the parameter. So the parameter, we're 95% confident that the parameter value, that the true value, the population value will be within this interval. Why is this called 95% confidence? Well, this corresponds to the 5% or 0.5% significance level that was used to decide whether there was enough evidence against a hypothesized value. So remember, we have that chart that says we look at the different levels and see, or we look at the different decimals, see, is there any evidence against the null hypothesis? If you notice, the 5% plus the 95% totals 100. So the 95% is called the confidence level and is a measure of how confident we are about our interval estimate of the parameter. And this is right from the textbook. You can read it. Hopefully you are reading it because it is a good textbook, but I just wanted to pull that together so you could see that. So a quick recap about sampling variability. We're going to talk about sample means this time. Last time was about proportions. This time you're going to do it based on means. When the variable, remember, is quantitative, the statistic is X bar, the sample mean or sample average, and S is what we use for standard deviation there. Remember, every time we pull a sample from the same population and we're doing the same number within the sample, let's say we pulled 100 every time, each of these X bars are based on that 100. X bar is going to vary from sample to sample. There's always sample variability. We can predict, though, how X bar will vary in relation to the value. I don't know, I keep having an extra mu value. So mu, remember, that's the parameter value for means. So remember, sample means have a distribution with mean, mu, and standard deviation, sigma over the square root of n. You're like, well, wait a minute. I thought, right. Remember, when a shape is approximately normal, remember for that central limit theorem, as long as either the sample is from a population or a process with a normal distribution, so they tell us it's normal. Is that likely to happen? Probably not. Or the sample size is bigger than 20. Bigger is better, up to a point. You don't want to go much, more than 5% of a population isn't useful. But remember, this stuff comes from the central limit theorem. So we have that, and we have all of our X bars in there. And remember that 95% of them are going to be within 2 standard deviations. Instead of, you know how we've always been at this point calling this standardized statistic Z? This actually is a little different than the normal distribution. This is actually called the t-distribution. In this class, we're not going to do much, but when we calculate standardized statistics from now on, we're going to use t, all right, instead of z that we are going to use for proportions. An approximate confidence, 95% confidence interval for mu So mu should fall within x bar plus or minus 2 times s over the square root of n. Remember, s is just the standard deviation of the sample. You will not have to calculate the standard deviation of the sample. Remember, that will be given to you. That margin of error is, 2 times s over the square root of n. So confidence intervals work very much the same way for sample means as they do for sample proportions. There's a study below I want you to work through. It'll review many of the concepts we've covered so far. Complete the lab before you check your answers, all right? That'll really help you understand. This is a great way to start reviewing. Notice we go all the way back to research question, looking at observational unit, what's the sample size, looking at the parameter of interest. We're looking at a little bit of everything here, all right? Then at the end, you're going to find, keep going here, you're going to use a theory-based inference. And then you're going to look at some p-values and look at what happens at the end based on your answers. What happens as sample size changes, standard deviation, S changes, and the sample average changes. All right, so you want to make sure you complete this. And like I said, short lecture today.